Hi, today we will be studying the topic of concavity. First of all, we will be discussing the need to study this topic. Then, secondly, we will discuss the concept. And at last, I will be telling you how to remember this concept. Consider f of x a function f of x equals to x cube plus 1. Now take the first derivative, that is f dash x. It will be equals to 3x square. Now put f dash x equal to 0. On putting f dash x equal to 0, what you will be getting? You will get that the turning point is at x equals to 0. Now, if you put the value of x equal to 0 in f of x, you will get f of x equals to 1, and f of x is also your y coordinate. So the point, or you can say the turning point or the critical point of the curve will be at 0 comma 1. Okay, now we will be using the concept which we studied in class 12th of increasing and decreasing. On putting f dash x equal to 0, we found that x equal to 0 is the critical point. So taking a number line and putting x equals to 0 in between, and then writing minus infinity and plus infinity. So here from 0 to infinity, x is greater than 0, and here x is less than 0. So what we will get now, if we put x as negative in the f dash x, we will get negative square, it will become positive. So here f dash x sign, that is, it will be positive. And here also, if we put the value of x as positive and positive squares in this, positive square will be positive. So the sign of f dash x here also is positive. Now, from this, what inference we can draw? We can say that f of x is increasing. F of x is increasing in the interval minus infinity, comma infinity. Now, I am going to tell you one more method apart from this, which you can use to tell whether the function is increasing or decreasing. So f dash x is equal to 3x square, right? So we know that 3x square is always greater than or equal to 0 for all x belongs to R, whether x is negative or x is positive. The value of f dash x will always be greater than equal to 0, and when f dash x is always is greater than or equal to 0, then we say that f of x is increasing in that interval. So f of x is increasing in interval from minus infinity to plus infinity. Now, using all this information which we have got till now, we can sketch the graph of the function. So this will be the graph. First of all, you will be calculating, or you will be deriving the X-intercept and Y-intercept. So let me tell you what is X-intercept. X-intercept is a point on the x-axis through which the curve passes. Okay, So it will be of the form, let me write, just a second. So it will be of the form x comma 0 form, right? Since it is passing through the x-axis. Now, so what you will do to find x-intercept? Just put y equals 0. So what you will get? You will be getting x cube plus 1 equals to 0 because f of x is the value of y. X cube equals to minus 1. X equals to cube root of minus 1, which will be minus 1, right? Now, then y-intercept. So what is y-intercept? It is a point on y-axis through which the curve passes. It will be of the form 0 comma y since it is lying on the y-axis. So what will you do to find y-intercept? Simply put x equal to 0. What you will get? F of x equal to 1 and f of x is the value of y. So we'll get the y-intercept as 0 comma 1. This is what I have done. X-intercept minus 1 comma 0, y-intercept 0 comma 1. So now we are sure that the curve will pass through these 2 points. One is 0 comma 1 and the other one is minus 1 comma 0. So what I did, I first plot these 2 points on the graph, and then after that I try to sketch the curve by using the information that the curve is increasing throughout minus infinity to plus infinity. So here, now just try to understand this. The curve is increasing and it is passing through this point and this point, right? But there are 2 ways in which the curve can be drawn if it is increasing. So the one way is it can increase in this way, right? Where the concavity is upward, right? And the second one, let me change the color. Okay, yeah. So the second one, it can go like this, with the concavity will be downwards. So here comes the role of concavity. So in order to sketch the graph, we need to study the concept of concavity. Let's try to understand the concept of concavity using the same question as we took earlier, f of x equal to x cube plus 1. So there are some steps which you have to follow while solving or sketching the graph. First of all, you have to calculate the x-intercept in the same manner in which we deduce the x-intercept in the previous part. Now, second, you have to calculate the y-intercept. Then, after that, you have to calculate the critical points. I'm not taking it in much detail because I have already discussed in the previous part. So, on putting f dash x equal to 0, you will get the that at x equal to 0 and y equals to 1 we'll have our critical point, yani ki at 0 comma 1 we have our critical point. Then the fourth point, you have to see in which intervals the graph or the curve is increasing and in which interval it is decreasing. So we'll get that fx is increasing for all x belongs to real number. Then fifth, you have to calculate the inflection point. So for that, first of all, find the second derivative f double dash x using f dash x, and then after that put f double dash x equal to 0. So what you will get? That x is equal to 0. Now there's one thing which you need to understand, that x equal to 0 is the inflection number and not the inflection point. So there is a difference between inflection number and inflection point. If you are taking just the value of x equal to 0, so this would be our inflection number. And if you on putting x equal to 0 in f of x, you get the value of y. So this point, if you get the point 0 comma 1, this will be the inflection point. So this thing you need to understand. Then the sixth one is concavity. Okay, so in this, let me tell you the concept. What we see is, we consider the sign of f dash x and f double dash x. We consider the sign of f dash x in order to know where the curve is increasing and where it is decreasing. We see the sign of f double dash x. Now listen carefully. We see the sign of f double dash x to know where the curve will be concave down and where the curve will be concave up. Okay, I repeat myself, that we consider the sign of f double dash x to know that where the curve, or in which interval the curve will be concave down and in which interval the curve will be concave up. So here also, now this you need to know, that if f double dash x is positive, then the curve will be concave up, and if f double dash x is negative, then the curve will be concave down. Okay, I repeat. So let's take this question only. So here, for x greater than 0, the sign of f double dash x was equal to 6x, right? So if we put x as positive in 6x, we will get f double dash x positive. And for x negative, if we put x as negative in 6x, we will get f double dash x as negative. So when f double dash is negative, it will be concave down, and when f double dash is positive, it will be concave up. So now we can easily sketch the graph. We know that the curve is passing through 2 points, -1, 0 and 0, 1, right? So in the part less than 0, where the x is negative, it will be concave down. So as you can see, it is concave down. And when x is greater than 0, that is x is positive, it will be concave up. So here I have drawn the curve as concave upward. So this is the whole concept of concavity. Basically, it helps us to sketch the graph of function. So at last, as I said, now I'm going to tell you that how to remember. Okay. So first of all, if we put f dash x equal to 0, what we get? Critical points. And if we when we put f double dash equal to 0, we will get the inflection points, right? Second, f dash x, if f dash x comes out to be positive, curve is increasing. When f dash x comes out to be negative, the curve is decreasing. And if f double dash x is positive, the curve will be concave upward, positive upward. And f double dash x is negative, then the curve will be downward. For negative, it will be downward. So this is a concept of concave up and concave down. One more thing which I want to discuss is like if we get a number line, okay, like this, and these are some of our inflection points. Let's say on putting f double dash equal to 0, you are getting these points. Let's say it is A, this is B, and this is C. So here, let's say you get the sign of f double dash x is positive. Here you get as negative. Here you get again negative, and here you get the sign as positive. So you need to remember this, that whenever the concavity changes, then only the point in between is said to be the inflection point. So if we consider the first one, that is for less than a and greater than a, the concavity is changing. The first of all, it is concave upward, then it is concave downward. So since the concavity is changing, A is said to be the inflection point. Now consider B. For for x less than b and for x greater than b. Okay, so for x less than b, what we have, the sign as negative. Then for x greater than b, we have the sign as negative again. So here the sign isn't changing. Okay, so first for x less than b, it is concave down, and then again also it is concave down. So B will not be called as inflection point. Okay, make this thing clear. Then let's consider C. So this you can easily tell, the C will be also be a inflection point, since the concavity is changing from concave down to concave up. Okay, thanks for watching.